let's take a look at the simple sketch graph of the quadratic graph y equals fx and the linear graph y equals gx. The two graphs have two intersection points with x coordinates x equals 2 and x equals 5. So there are times when you might need to interpret the solutions to inequalities graphically considering the graphs of the functions that are related to them. So, if you take a look at these graphs, the quadratic graph y equals fx is above the linear graph y equals gx when x is less than 2 and when x is greater than 5. The values of x for which the curve y equals fx is above the line graph y equals gx satisfy the inequality fx greater than gx. The curve fx is below the line gx when x is greater than 2 but less than 5. The values of x for which the curve y equals fx is below the line graph y equals gx satisfy the inequality fx is less than gx. For example, fx equals 3x squared minus 2x minus 1, gx equals x plus 5. Now, find the set of values of x for which the curve with equation y equals fx is below the line with the equation y equals gx. First, let's sketch the two graphs on the same axis. Y equals 3x squared minus 2x minus 1. When x equals 0, y equals minus 1, and when y equals 0, 3x squared minus 2x minus 1 equal to 0. Factorize, so 3x plus 1 times x minus 1 equals 0, x equals minus 1 over 3 or x equals 1. Y equals x plus 5, when x equals 0, y equals 5, and when y equals 0, x equals minus 5. So here you can see the two graphs of y equals fx and y equals gx. There are 2 points of intersection. Now let's find the coordinates of that points of intersection. You can either read the coordinates of the graph or set fx equal to gx to find them. So I'll just use algebra here. So 3x squared minus 2x minus 1 equals x plus 5. 3x squared minus 3x minus 6 equal to 0. Factorize, so 3x minus 6 times x plus 1 equal to 0, x equals 2 or x equals minus 1. There is no need to find the y coordinates, but I'll show them for reference. So the points of intersection have the coordinates minus 1, 4 and 2, 7. As you can see by the shaded area, this is when the curve y equals fx is below the line graph y equals gx. So fx is less than gx when x is greater than minus 1 but less than 2. And hence the solution is x is greater than minus 1 but less than 2. Fx equals minus 2x squared plus 5x minus 4, gx equals minus 2x minus 1. Find the set of values of x when fx is less than gx. So here are the two graphs for y equals fx and y equals gx. Now let's find the coordinates of the points of intersection. So set fx equal to gx. Minus 2x squared plus 5x minus 4 equals to minus 2x minus 1, minus 2x squared plus 7x minus 3 equal to 0. So factorize to find the x coordinates, then it's 2x minus 1 times 3 minus x equal to 0, x equals 3 or x equals 1 over 2. And the y coordinates are when x equals 3, y equals minus 7, and when x equals 1 over 2, y equals minus 2. So, the coordinates of the points of intersection are 3, minus 7 and 1 over 2, minus 2. As you can see from the arrows, the curve y equals fx is below the line y equals gx when x is less than 1 over 2 and when x is greater than 3. And hence the solution is x is less than 1 over 2 or x is greater than 3. Fx equals 8 minus 5x, gx equals 14 minus 3x. Now, let's write down the solutions to the inequality fx is less than or equal to gx. Let's sketch the two line graphs first. So, y equals 8 minus 5x when x equals 0, y equals 8, and when y equals 0, x equals 1.6. And for y equals 14 minus 3x, when x equals 0, y equals 14, when y equals 0, x equals 14 over 3. Here are the two line graphs of y equals fx and y equals gx. There is one point of intersection, so setting fx equal to gx gives us 8 minus 5x equals 14 minus 3x, minus 6 equal to 2x, x equals minus 3. The point of intersection has the x-coordinate minus 3. As you can see from the graph, the line y equals fx is below y equals gx when x is greater than or equal to minus 3. And hence the solution to the inequality fx is less than or equal to gx is x is greater than or equal to minus 3.